All right, good morning or good day, wherever, depending on where you are in the world. All right, so yesterday we talked a little bit about how fun it was. We're doing assessments and different units and such. But I wanna look at a little bit of process stuff. At the analysts, our process is pretty unique in the fact that we try to create a team of the right people, and we are assessing systems, or we are assessing systems based on one key problem, not a generalized approach. So I want to show how that works in a situation with this dairy plant that we've been working at here in Ljubljana. And I want to show some of the process and give some clues and maybe some tips about how you can attack similar types of issues. So let's look here. So the customer system, they have a compressor room here. The piping leaves the compressor room and it comes down to the first building here. This pipe extends to a second building there, and at this specific machine, it's labeled machine 3, but at this specific machine, point 11, they are getting low pressure alarms. They're intermittent. Sometimes they can last upwards of 12 minutes. Sometimes they're as short as 10 seconds. There was data collection taken of pressure and flow at point 11. I want to say it was taken for a week or two, but they saw periods of pressure underneath 90 psi 6 bar, which is what the set point is. And like I said, they saw it for as low as like 10 seconds, and they saw it upwards of 12 minutes. The customer's specific problem is that this low pressure alarm is shutting down this machine, and they would like to know what the root of that problem is and how to prevent the shutdown of production. So after we learned what the customer's problem is, we did a walkthrough assessment. We collected all the data on the equipment, the compressors, dryers, filters, receiver tanks, pipe sizes, layouts. We walked through and looked for instrumentation. We interviewed stakeholders, and we just tried to gain as much information as we could through what we call observation method, right? Now, after this observation method, we have pictures, we have videos, we have interviews, we have machinery data. We have all the information that we could see in a visit to the facility. But once we do that, now we have to look at it and say, okay, here's all the information that we were able to find. What's missing? What's missing, right? We need to find out pressure right here is not good enough. Now, mind you, the customer's concern is that this machine is shutting down. They don't necessarily care about this pressure. They're trying to know why. They want to prevent this machine from shutting down. And here, my argument here is that air still doesn't matter. Compressed air does not matter, even in this case. They don't care if it's cows falling from the ceiling. It has nothing to do with compressed air. To this customer, it is only about that machine, that production shutting down. Now for us though, we saw this at the point that the pressure sensor is shutting off the machine. The machine is being shut off by low pressure here. So once we verified with data collection that pressure was actually dropping, right? Point is there a problem, or does it think there's a problem, right? So when we talk about sensors, if you have sensors and alarms, right? The alarm could go, when the alarm goes off, we have to ask, is it real or does it think it's real, right? So we have to verify, is that pressure reading what it thinks it's reading? That was done. So now We know that we're having pressure drop here. We know we're having pressure drop here. We looked through the machine. We looked at they had from that main line in, they had about 10 process points, all with regulators that went to different areas of the machine. But we took all this information and we said, okay, what's missing? What are we concerned about for, calibration? What, does it make sense? Are there things that don't make sense? Does everything add up? What, in order for us to create theories about what the concerns are, what do we have to assume, right? Because even in those assumptions, that helps us know what we're missing, right? If we had all the data we needed, we wouldn't have to make assumptions. But without that, we need assumptions. What is the risk of those assumptions? Well, what the risk is, one of the big risks is that you tell the customer that this is what the problem is. They spend money, time, resources, and it doesn't fix it. So that risk sucks. So for me, I don't like that. But there's an interesting thing here, and I wish this wasn't true, but I would go as close to 100% of the time that I can and say that we go into plants almost every day. Every day somebody's complaining about inadequate flow, inadequate air quality, pressure, temperature's wrong, something's wrong, right? And then we come back to them and say, well, where's your instrumentation? Where's your measurements? Yeah, we don't have that. Well, the thing that bothers me a lot of times is that if we're not measuring it, how do we know? Like, we are limited. Our hands are tied to assumptions and rules of thumb and mistakes. We make mistakes all over the place when we don't have the data. But when our customers or potential customers fight us on the data that is important to what they're asking, we get a lot of pushback. So here's why we have to put this back to the customer, and we have to put that risk onto them. And this is not an easy thing to do, but we have to put the risk back onto them. And here's how we do this. We do our walkthrough assessment, and we gather all the information that we can, and we put together a list of assumptions. We put together a list of possibilities. We put together where our concerns are, and then we go back to the customer and we say, assumptions are data, or some variation of, right? Assumptions add risk immediately. But instead of assumptions, we offer them a solution, and we say, hey, based off this, you're wanting to know, hey, if we connect this pipe, will that reduce this problem? If we increase pressure here, will that reduce the problem? If we increase this pipe size, will that reduce the problem? If we put a check valve here, would that reduce the problem? If we put a receiver tank here, would that reduce the problem? We can assume all day and just take shots at it. What do you call that? Like parts changing. Or we can say, guys, here's the data we have an understanding of, right? We looked in here and we know we have pressure drop. Immediately the gauges are going, wrong way, right? When the machine cycles, right? So we have to create a boundary with the customer and say, is our boundary outside of this machine? Is that the limit to our system, or are we getting inside of it? Because if we get inside of it, now we're looking at tubing size increases, we're making sure the regulators are the right size, we're making sure the cylinders are correct, that we're actually using air correctly in here. Now, a lot of times the customer will determine for us that the boundary is outside of the machine. Now, if the boundary is outside of the machine, then we're going to be forced to use our process tools to respond to the needs of the machine. And we need to figure out what that is to account for this and variations on this. It's important to note that we have to have an understanding that we have to understand if this machine can change speeds and the impact of compressed air utilization if that machine operates at different speeds. If it just operates at one speed, then it's easier, much easier to use process tools to like receiver tanks, regulators, amplifiers, all the stuff that we can use right here, filtration, drying, to give the air that's required for right here. Now, when we want to know is there two problems, right? Is there a problem in the machine and a problem with the distribution? Now we say, okay, now we have to figure out the pipe size here, right? So we know this pipe size is DN50, but we don't have data on these other machines on the same line. So if we want to figure out if this is correct, then we need to have an understanding of the what's happening here and what's happening here. So we need to be taking flow and pressure here, and we need to see at the best interval possible, we need to be able to see what's going on in this line from this against these other machines. That will be able to tell us if this line is sized correctly and or if there's a benefit to tying in this. But if we notice that there's also a problem here, this is where it gets really fun. And my friend and colleague Jan and I were talking. So if the problem is here and this is inadequately sized, the problem could be here and the sensitivity increases here. Now, but if there's also a problem here, then issues here would make the system more sensitive to this problem, right? So you have problem sensitivity, and then you have problem sensitivity, and they work against each other to create intermittent problems. But back to what we were talking about, we have to ask the customer, do you want to make assumptions and just start taking swings at things? Do you want to add pipe there? Do you want to increase this from 25 millimeter to 40? Do you want to add in a receiver tank? Do you want to do all these things? Or do we actually want to get the measurements that we need, get the data we need, and figure out what the problem or problems are and solve it one time with confidence? So that's our extremely long-winded troubleshooting process. I really hope this connected with somebody. But as always, stay safe out there, okay? Seriously, stay safe.